It's my pleasure to introduce Matt Friedline, who will be leading the discussion today. Go ahead, Matt.
Thank you there, Mike. I will go ahead and share my screen here. And thank you everyone for joining here today. And Mike, can you confirm you see my screen all right?
Yes, I can.
All right, thank you. And yes, thank you everyone for joining today. I'm here representing the Modernized Forecast Process Working Group, and you can see the names of the team here. And on today also have Rich Kinney and Sean Jacobs, who will be helping as we take a look at the forecast, do a live demonstration walkthrough. And it's a good day for it, looking ahead with some active warm pattern in the days 3 through 6 time, which we'll explore. Just a few things on what the working group's been digging into here recently and what's upcoming. And you may remember we presented on the last day of July too, and not much has changed since then in terms of what's upcoming for the early fall and some training releases. But we'll just touch on that as well as a look at some reminders here. Today, as we look at the Modernized Forecast Process and do a walkthrough, here's sort of that overview infographic. And today we're really going to be focusing on parts 2, 3, and 4 there. And we hope that in this past year that these 4 steps you've been seeing integrated into your workflow day in and out at your office here. The key with this here is that we're looking at the data sets not only deterministically but probabilistically, and we're marrying that with the vulnerability aspect too, and identifying messaging opportunities throughout the process, and then that importance of communicating that. And that, especially nowadays, means effective key messages, which support all of our different forms of messaging that we have. When going through the forecast process now, we stress always having that idea of what the end messaging will be. And that development takes time as you look at all the science and the data and you apply your conceptual models here. So identifying those potential messaging opportunities often happens early in the shift, but you don't start with a blank slate, of course, too. You have the previous shift and your inherited forecast and messaging there too. And then refining and adapting that as you look at new data. When looking at determining whether a message what the messaging needs to be and how it needs to be conveyed, this little chart here can help with that. And confidence is a big part of that. And so throughout the forecast process, you're weighing and evaluating your confidence there. So the probability of a certain event and its degree of impact are 2 questions you should be asking yourselves regularly throughout the forecast process here. And this little infographic will keep in mind here as we look at today's weather going forward, or today's forecast going forward. Rich and Sean here, as we look at the data and the science, they'll be crafting key messages here for the forecast and the areas in which we're looking at here. We've been doing key messages across Central Region consistently, all offices here throughout 2024, but I know numerous offices were already testing and looking at them prior to that. So we should be in a pretty good rhythm. But this will be part of some of the fall training too that we'll be releasing as a working group here coming up, and toward more consistent key messages and some best practices with key messages. And that's what today's live walkthrough will hopefully demonstrate too. So here are some of the main objectives with key messages here. And you can see them in the infographic here too. I won't read them all, but that'll be some of what we're working toward here today, and what you'll see in the training release that will be coming this fall as well. And so here is a look ahead here, and we may touch on this at the end too. But again, we're on the CR speaker series about each month here, and then a release here in early autumn of some short training vignettes on the MFP. We'll have a presentation in late October on the fall symposium, and then we'll continue to integrate this modernized forecast process and review best practices and share them among our offices here as we head into the cool season here. So with that, I'm going to jump now to, I'm actually going to launch a poll everywhere question here at first here. And so I'm going to post in the chat what you will see here will be a poll everywhere that you should be able to log into. And one of the things our group has discussed is the importance of operational best practices, the modernized forecast process. And that is starting the shift off right. And there's a lot that goes into that. And that's going to be something we touch on in the training vignettes. But we want to hear from you too. What starts a forecast shift off right for you? That starts it on a good note, on a positive note, toward being able to dig in the data in the right way, to know what to look at, what to focus on. What are some of those in the operational workflow best practices that you have seen? So this should be a word cloud here, and we want to sort of see what you at your offices use and get that shift started on a good note. So there's sort of a culture component of this as well here. Seeing some notes on briefings and AFD here. I like the coffee. That's a day shift one for sure, and a mid shift one. Leave this open for a little bit longer here. I think our working group here, I know Rich and Sean, as they're watching this here, we have to be happy at what we're seeing, because our training will talk about this this very thing about an effective shift briefing and how important that is to lead yourself, to lead the team in the right direction there too. Yep, and yeah, we see a lot of good things here. The AFD, or in other words, your inherited key messages too. What you're starting with, that's a big deal there. So we appreciate everyone joining in with that there too. See a couple things we'll take to for our vignette training as we finalize that too. The uncertainties. Yep, that's great. We appreciate everyone joining in on that. All right. Well, now we'll jump into the weather briefing, and we're going to start on that note here of looking at what the inherited messaging is. And today we're going to take a look at the Plain States, particularly Rapid City area and in the Omaha area. These are areas that, as you saw in the morning briefing this morning, look like we'll be experiencing heat coming in here late this week into the weekend. And we're particularly going to look at the weekend, Saturday and Sunday, and look at deriving some key messages based on the data platforms that we're very used to and comfortable with here. So first, inherited message. This is just a look at Rapid City's general weather story today. We won't dig into this too much, but looking at Saturday, sort of the ballpark that we're dealing with here, and you can see the note across their area, a temperature range, but that high mark, 100 degrees, triple digit potential there in western South Dakota. And then in eastern Nebraska here for Omaha, again, focusing in on this weekend here, highs well into the 90s, potential also for triple digits there. So just kind of a quick look. Obviously, it's not that full shift briefing. The key messages that several of you mentioned with the word cloud responses there, but it at least gives a feel for what those offices have been looking at here. So we will start here. One of the first things, if you remember from that infographic that we shared, is looking at hazards and that vulnerability overlap. But a foundation to that is exploring the forecast pattern, that basic science that so many of us love with our job, looking at that forecast funnel and those fundamentals there into the general pattern. So we all have our favorite sites and pages in AWIPS procedures to look at that. I'm just going to use DESI here for this instance too, and a reminder that DESI does offer that. So what I'm looking at here, and a lot of things we'll walk through and click through. In the interest of time, I just sort of had this first one up here with DESI here. But the upper levels here, for instance, are available for looking at synoptic mass fields and looking at the basics here. And this is especially true with the long range ensemble forecast, or the LREF here from the drop down there. So that's taking the longer range, a little lower resolution compared to some of those near-term CAM models within the NBM here. And so what I've selected here is the second one under 500 millibars here. So just looking at basics here. So it loads 3 data sets here automatically. It's almost like a procedure in AWIPS. It loads it for us here. So we're going to look at the tail end of the work week here, Friday into Saturday here. And so we have our Omega block that we've had. It's not the strongest of blocks, as the upper low on the East Coast and toward the Northeast is on its way out here, but very amplified across the Western and Central US, especially for meteorological summer here. And you can see this pattern. This is a look at Saturday afternoon here, and you can see the closed low moving onshore, the ridge building into the Missouri River Valley there. Keep in mind the areas we're looking at here in South Dakota and Nebraska. And then into Sunday, a shifting east. The upper low looks like, at least in the mean pattern, getting absorbed in the northern stream as it moves northeastward there. And then into Sunday afternoon, the ridge centered more toward eastern Kansas into the Corn Belt there. One of these things, looking at basic fields too, this is where you get calibrated with, and the veteran forecasters know some of those values. For instance, the 500 millibar heights, they're 594 decameters. In Iowa and the Corn Belt in meteorological summer, without clouds or precipitation, that's usually good for 90 plus. That usually translates to some good warmth there. So with a lot of these things, with probabilistic data and ensembles, we still encourage that basic look at the pattern and the pattern recognition. That's so important to us, and that's where that forecaster still has that little lean over machine there. And we'll talk about that in the vignette training there as well. So looking at just conceptuals here, we'll take a look at the 850 here. So given what we've looked at with the 500 millibar ridge placement, it would not be surprising to know that a low-level thermal ridge is of interest here for potential heat, and looking at that and just quantifying that. So this is a look at the 850 millibar temperatures and the advection as an area there. Kind of like that to show where the low-level jet, maybe its maximum, where you have that warm air advection, and potentially where there might be some convective issues here. So there's Friday night. You can see toward the Omaha area, the thermal ridge building in, and some strong temperature advection noted there. And then we'll stop here on the Saturday afternoon time. So I'm going to zoom in here and look at sort of that 850 thermal values here towards Rapid City. So about 30 at 850. We're going to keep that in mind. For a lot of us in Central Region, that's a pretty high value. For out there in some of the higher country, we'll have to see. We'll have to calibrate. We'll look at ways that we can quantify that. That's not as far off the ground as say us here in the Corn Belt there. And then we'll look at Sunday here, and we'll see as we get to Sunday afternoon, the thermal ridge here, again, it's leans more northeast towards Omaha, so around 27 degrees there on Sunday. Kind of keep that in mind, 27, 28 or so there for Sunday. So we'll kind of keep those values in mind as we look at things. Notice that the ridge eases, at least on this mean solution, toward Rapid City here. And then we'll just glance real quick at the surface pattern here too. Won't spend too much time on this. We can probably almost paint what the surface pattern is going to be given the synoptic upper levels here. So here's a look at Saturday afternoon. There's a low, not surprisingly, here in Montana, up in the Saskatchewan there, and that helps to support the warm advection in the plains across the entirety of the plains there. Maybe a strong or developing warm front there across Kansas ahead of the real high-end warm air there, lifting north in the plains. And then as we go to Sunday, we'll see that heat and that trough area has shifted out into the plain some. That might speak to the little bit lower temperature values potentially at Rapid City, but a warm setup for Omaha. And while we're on the surface, let's just look at dew point. And a reminder here, as you look at the DESI fields, if you don't see mean, but boy, you'd like to just see what's sort of my average dew points here. When you click on statistics, that will give that opportunity because you have the ability to look at the percentiles. And so that includes the mean or the median as well there. So we're just going to look at the dew points here to see if heat index is a potential factor that we have to consider given the potential for high-end anomalous warmth here. So as we look at Saturday afternoon here, and I'm actually going to put the contours on. I sort of like those a little bit more. As we look at Saturday afternoon here, we're in the mean forecast here in the 40s to maybe low 50s across the Rapid City CWA, while Omaha more towards 70. And a classic corn belt in August here, more toward 70 dew points there. So it seems like the dew point's more of a factor there. But remember, Sunday looked like the potential warmer day there for Omaha. The dew points on Sunday are upper 60s, low 70s, even a little lower here toward Rapid City. So as is common, Rapid City, more of that dry, arid air mass there, and Omaha looking more moist. So no huge surprises there in looking at the surface fields. So we're going to glance at the cluster analysis now, and this can be used to look at predictability of a pattern, which gets more into the next step of the modernized forecast process as we step through. But given we're looking at big scale synoptic features here too, it's nice to see how similar are the models in predicting that, just sort of overview big picture as well here. So we're going to take a look at that and look at the solutions here, the main clusters. Again, as a reminder, this is some of the primary ensembles, the Canadian, the GFS, and European ensembles here, and their solutions broken into 4 clusters of similar mass fields. And then the ensemble mean is shown below here. So what we're looking at are just anomalies here on the 500 millibar heights, real basic. And this is at day 3, which, as you can see, ends at 0Z Sunday. So this is basically Saturday, Friday night and Saturday. You'll notice no large-scale differences. As we start to get in the heart of the cool season, winter storms, I think a lot of us start using these more regularly, maybe than some of the heart of summer. But there are some benefits here in summer to see. But we don't see major differences here on day 3, including the degree of anomaly. Now, as we go to Sunday here, which is day 4, we do see some differences here, especially as it pertains toward Rapid City and potential weather or potential pattern that could influence sensible weather. We see these clusters here on the left-hand side, more of a closed circulation and slower still, as you'd expect with that, while the ones to the right here, more phasing with the northern stream and bringing some of those height falls into the western and high plains there as the ridge starts to shift east. So this could potentially result in some temperature differences here. In terms of looking at how many models are showing that, or is there a certain type of model ensemble that members that are showing that? This is where these percentages here show that. And we'll see in the totality here, 33% and 21%. So that's near half that are showing this closed low, slower solution, probably warmer, which we'll look at for Rapid City, versus these sort of quicker progression of the trough. It's almost half and half there. And there's not necessarily a certain model group in here, maybe more of the Canadian ensemble, keeping that closed low, and maybe a little more European ensemble than GFS, but there's not necessarily one strong family over another. So let's look at those temperature differences here. So this is maintaining the same clusters that we just looked at, and the temperature differences from the multi-ensemble mean here. So this is not anomaly, this is differences now from the mean. And not surprisingly, for that western South Dakota region, we see warmer temperatures with the scenarios that these clusters are indicating, which is more of a closed, slower low in the Intermountain West there. And then with these, a cooler solution on the right-hand side. Got my light set to drop off there, so if you have the camera on, you may see my light went off. That makes me get up every half hour there, so that's why it went in the dark there. But you'll see those temperature differences, and that'll be key to keep in mind here as we dig into the data here with that. So we will now jump to look at some standardized anomalies. One thing I'm going to mention real quick too with QPF, if this was more of a precipitation scenario, you'll see this link here that'll go to a QPF clusters page through WPC. And that will give more information about QPF. This is what that looks like here. And I'm not going to go into detail on this because this is for a different area, but this is an example for Sunday night, Saturday night into Sunday for a little further east in the Corn Belt. And you can see how clusters are behaving in their membership with precipitation output. Here's, for instance, the multi-ensemble mean for that time, indicating some potential warm advection precip over toward my CWA DVN, but one cluster indicating more of an footprint with that, maybe a loosely defined MCS. So something for my office and St. Louis office to be looking into today for that. But looking at anomalies here now, and I'm going to switch this to the standardized anomaly for the CONUS here, just to show big picture here at first. And it's not a surprise at all in the mid-latitudes with some type of synoptic system in the country, which is almost always, that you see some degree of high anomaly somewhere in the country being reported. That just happens here. So we'll see that, but we can zoom in to the north central US here. And then when we click the table will update there, and we can look at temperatures. So here's, for instance, let me click on this one here, 0Z Sunday, which is for Saturday afternoon. And so we can see the degree of temperature anomalies here. In the heart of summer, which we still are at, sometimes you won't see these extreme anomalies like you may see in the transition season, but they still may be noteworthy, 2 to 4 C anomalies, for instance, at 850 there. So that's something to note there, that the 850 anomalies around 2 degrees above normal, or so 2 to 3 degrees above normal there. Notice pronounced mid-level temperatures, which may have an effect at keeping convection on the periphery there in that warm air advection that we saw either at bay, or at least preventing it from being maybe severe or long lasting, giving such strong 700 millibar temperatures there. So that's just a quick glance at anomalies. A reminder, you can look at percentiles there as well to sort of see where you fall on that. The EFI here, the Extreme Forecast Index through the European, is a nice way here to look at and quantify the potential for an extreme event, and then if so, just how extreme of an event. So here's a look at the CONUS from last evening's 0Z European ensemble run here. So we can see here, when you get to the 0.5 or minus 0.5 or greater each way, that's indicating the potential for an unusual event. The likelihood increases as you get greater, or your confidence, in other words. More model members are showing that in the European ensemble of an unusual event. And then that shift of tails can help quantify how extreme the event might be as it approaches 1 there. So as we can see this, and we're going to click here so we make sure we're on the right values. So we're looking at Saturday temperatures here. So that's going to be Sunday 0Z. So again, for Western South Dakota there, looking at that there, we do see the EFI shaded there, but we don't necessarily see a shift of tails. So the potential for an extreme event isn't showing up right now in that data. And then we'll look at Sundays too, and we'll still see some shading. It eases a bit, but again, the shift of tails is limited. Greater shading for Omaha area as that thermal ridge leans over there. But again, the shift of tails for an extreme event, in other words, where that model climate or the ensemble forecast, those top 10% are also in that tail end of what the model has forecast, or the model climate for the European ensemble. We're not necessarily seeing that in those areas there, but at least indicating an unusual event, anomalous warmth there for those areas there. And then the last thing I wanted to look at for this step of the forecast process is just the SPC sounding climatology. I know many of us may think of this as sort of an observed or real time when our balloon's up or when our nearby RAOB has been launched, but it also has a place for forecasting out hours or days and to see where you're at with respect to the environment or parameter space. So we'll look at Rapid City here. And this is 850 temperatures. Remember, we were seeing 30 C there for Saturday. And what's really nice about this page, we can zoom in here. So let's zoom in on a period sort of focused on late August here. And so 30 C for this weekend, that sort of time frame, that's near the top there. That's near record territory for them. It's not that much below before you're in normal there, just with the nature of the climate out there this time of year. However, 30 C is really noteworthy for them for warm, hot values translated down to the surface. And then we'll glance at Omaha as well. Same thing here. Remember, we were seeing 27 C in that area here. So we'll look at Omaha for that. So 27 C here in the Omaha area. That's also getting near there. It's in the upper 10th percentile for sure, probably even the upper 5th percentile there in that area for Sunday. Remember, that was more for Sunday that we were looking at. So that's kind of a nice portal to put the environment in context there. So we're going to have another poll everywhere question. So if you still have that link up, or it's in chat there. And this question here pertains to what we've just looked at here. So how commonly do you use those anomaly data sets in your workflow that we've looked at so far? And as we start to drill in, we'll look at some other data sets, but just wanted to see for our group how commonly you're looking at those data sets. All right, we'll give it just a few more seconds here. And we can see a correlation to when there's potential high impact weather ahead. And obviously, we talked about the evaluation of that early on in the forecast process. Sometimes we get those sneaky events too, although sometimes those are the ones that what makes them sneaky is they don't show up markedly in the ensemble data too. So you have to sort of dig in and define those. All right, looks like the results have kind of stopped there. So it's good to know about 2/3 of the answers tied with high impact weather ahead. So thank you there for filling that out. That feedback's helpful to our group here. So we will jump ahead here, and now we're going to look at that next phase of the forecast process, which was evaluating the predictability and then identifying messaging opportunities. You've probably already been thinking about the messaging, on the heat end, but the evaluating the predictability. The clusters can help with that, especially as it comes towards precip in that. And if you have different depictions of the lows or the forcing mechanisms within the model data. But also we can use ranges and spreads in data and looking at the upper percentiles of data to see what may impact. And when we think about heat, especially in the Midwest, we know cloud cover and then certainly convection may be inhibitors to reach the full maximum of heat here. So I already have this loaded up here in the interest of time, but this is sky cover, and this is from the NBM here for the area of interest. And I'm actually going to load the 75th percentile. So sort of looking at what that upper quartile would look at in terms of sky cover. So maybe leaning toward what would be a worst case scenario to see if cloud cover would impact things here. So we're going to look at, this is late morning Saturday into early afternoon. So first for Omaha on Saturday, can see some footprint here that aligned with our warm advection at 850 there of potentially some cloud cover, whether that be precip or convection there, not necessarily certain on, but some signs of that, and then that exiting here at 4 p.m., 7 p.m. Rapid City, again, we're looking at the 75th percentile, pretty high confidence there in this model data from the NBM, this run, that there probably wouldn't be much for clouds impacting that there. And then we'll go into Saturday night, and we see some clouds coming out ahead of the trough toward Rapid City there. And then as we go into the day Sunday, remember Omaha is especially of interest here on Sunday, 1 p.m., 4 p.m., again, toward that confidence of having enough sun there, or plenty of sun there to support the heat. Remember, we glanced at the WPC QPF clusters, and you can sort of see some semblance of that, where the warm advection is on Saturday night into Sunday over in the Mississippi River Valley for some potential precip there and some lingering cloud effects. But that's a look at that. We'll look at precip now here. And for the cloud cover, by the way, that's just under the upper levels there. But we'll look at precip here and the probability of precip. As you get in the near term, you look at higher resolution time windows, but when we're out further, 12 or 24 hours can help. And if the precip is a multi-day precip, then we're starting to look at more than that. We're just going to look at the probability of 12-hour precip here. And we'll start with greater than 1/100 of an inch to see if we have any issues here potentially. So this is a look at Saturday during the day here. As we can see, Rapid City NBM membership, almost none giving precip there, only 5% there indicating some precip. As we look toward Omaha here, this is in a Saturday morning and then into Saturday afternoon. Again, we can see some semblance of influence with that low-level jet Friday night and the Saturday morning of possibly some precip there. In the maximum area there, about half the membership giving 1/100 of an inch of precip there. And then we'll look ahead to Sunday and very little influence or very little precip signature for Omaha and not too much of one for Rapid City either at that point still. Sometimes I like to look at the probability of, say, 5/100, bump it up, that spurious 1/100 or a couple hundredths. I know we've all seen that. It doesn't take too much to get that in the model data. So we'll look at that for like Omaha there. And we still see some semblance of that there down that Saturday morning time frame. So that could be an influence to some heat there at Omaha on Saturday. But come Sunday, that looks to be mainly east of the area there. So that's one way to evaluate precip there. If we were expecting more precip, we could look at something like the C shield there to get an idea, an extended cam there, to get an idea what the footprint or mode might be, especially if you're worried about a severe weather. But since we don't have that today, in the interest of time, we'll skip that. Going to glance here at the 1D viewer. Now, this is available here. It's also available in the What's Up viewer. You can drill down to a location and look at the 1D viewer. Here's a look at Rapid City here, and I'm going to zoom in on the temperature plot for Saturday and Sunday on the weekend. Now, here's a look at the Saturday temperatures there, and what I've got displayed here, I have the default on, which is a reminder, the middle half of the data, or the 25th to 75th percentile, is your box there. So that's 100 to 103 degrees on the NBM there, where Sunday, a much wider range, 89 to 100, and that's just half the data. You've got 25% above that, 25% below. So some uncertainty with that trough ejection time and that influence down to sensible weather there on Sunday for Rapid City. Now, we know with the NBM, I won't get into the details on this, but with the quantile mapping and the bias correction, sometimes there can be influence depending on your recent weather pattern, maybe too warm or too cool there. That's where the local ability there, the local forecasting knowledge helps. Also topography as you get toward Rapid City, and that becomes a key too. So again, that local forecaster insight and knowledge of how things have been and any NBM biases you might be aware of becomes really important there. We'll just take a quick glance at Omaha here too, and see their spreads. And probably what we would expect is that Sunday for Omaha probably has a narrower spread than Saturday. And that is indeed the case there. And so we'll take a look at the ballpark here, upper 80s to mid 90s, Omaha area on Saturday. So still warm, but look at Sunday, solidly mid 90s in the NBM data set, and even upper 90s are within that 25th to 75th percentile range there. We can also look at European mediograms or GFS ensemble mediograms as well within Weather Bell. Just do a quick glance here at Rapid City, and here is your Saturday period here. You'll see sort of the small box and whisker plot and see where the data is. For the European ensemble membership, these numbers are a little bit below the NBM that we just saw. You'll notice there's a lot of upper 90s in here versus triple digits. There's a handful that are triple digits, but most are upper 90s there. But look at how many. There's all the data is in the at least the mid 90s or higher practically. So it doesn't seem like much for failure modes at Rapid City for a hot Saturday there. It's just a question of how hot there. So I wanted to show an example of that while we had it up there. And then within DESI 2, we can look at the temperatures here, and you can look at the statistics for the max temperatures, for instance, and you can look at percentiles as well on here, just sort of a reminder on that. So like the 90th percentile, for instance, on the max temperature here. And then you can sample the data. So for instance, Rapid City, and we can see with Rapid City, topographic influences, they're make a big difference here. But near and just east of Rapid City, the 90th percentile, they're several degrees above 100 here, for instance, there. And toward Omaha there, that's also very high on Saturday. But remember, that spread is higher at Omaha on Saturday. And then here's a look at Sunday there. A look at that for Sunday. You'll see a little less there for Rapid City, and about the same for Omaha, but we know there's less spread in the data there for Omaha. So there is potential for triple digits, as Omaha noted in their weather story. We still see that too here with that upper end solutions there, and they again have the dew points as well. So we'll look at probability of exceedance here, which is really nice feature in DESI. And so the max temperature, we can look at the probabilities here, and we can look at greater than 100. For instance, we'll first look at 95 here. And so we'll look at this. This is using, again, the full NBM data set. It's always important to remember what data set you're looking at. And so here's a look at Rapid City. Not a surprise, 95, very high. Notice in Omaha here, we get that gradient, that uncertainty area there on Saturday there. And you can see 40% of the members above 95 for Omaha. As you head south of there in their CWA, that starts to increase and kind of quickly as you head into Kansas there. And then we'll look at Sunday at Rapid City there. We've got about 50% of membership over 95 there. Again, that uncertainty, how quickly the trough ejects. Omaha there for Sunday, much higher confidence, exceeding 95. And then we'll look at the triple digit mark here of 100 degrees for Saturday. Rapid City there, over half the data, near 3/4 of the data, exceeding 100 there, at or just east of Rapid City there. Looks like a favorable topographic location, but low probabilities of triple digits in Omaha's area on Saturday. Sunday there, kind of quantifying that ability of the ability to reach 100 there. You're about 1/4 of the membership or so, south of Omaha or so, about 1/4 of the membership there, exceeding 100 there. So that's a quick way to quantify probability of exceedance. As for heat index and apparent temperature, and this has been some recent chatter in the Sioux world too, you may notice that the probability for apparent temperature doesn't show with the full NBM data set. In time, that will be coming, but if you want to see that, or if you want to have some ability to quantify probability of exceedance, the long range members will have that. So then we'll go to the 2-meter apparent temperature and we'll see probability of exceedance, and we'll look at that for probability of exceeding 100 here for apparent temperature here. So we'll take a look at that, and we'll look at Saturday first here. And so not surprisingly, with Rapid City's dew points there, low probabilities, but at Omaha there, quite the gradient there of exceeding 100 there. So you start thinking about impacts and heat headlines and expressing that in key messages for 3 days out, the weekend time for Saturday. That is quite the range there for Omaha. 2/3 or so of membership indicating that for their south, but almost none by the time you get north of Sioux City there. And then for Sunday here, then in Omaha, a little over half the membership indicating heat indices over 100 for Omaha there for Sunday. And then we'll just show the weather in context here, which I know many of you may be familiar with here. This is a look at what the NDFD has. So remember, this is what our current published official grids have. Notice no record highs forecast here in the domain area. Some record warm lows forecast, though, for Saturday night, that or record lows that are close to being forecast as well are shown. So that's 68 for Rapid City there. That's within a couple degrees of record. So a warm night there as well. Warm nights Friday night and Saturday night, that the calendar day Saturday would be forecast at that. You can also look at what the NBM has with that as well. No record highs forecast, so we're not in record territory. Remember, with the shift of tails and other data we looked at, we're not necessarily in record territory for highs, but we're hot in the data. And then our lows are pretty warm in this region here, within a few degrees of record there. So that's a little on the weather in context. One other thing I'll just show real quick here is with the warmth in like Rapid City, that heat, often one of the things to look at, and in the plains as a whole too, is fire weather a concern in looking at that. And so a nice feature of DESI is to load multiple variables, as we saw, but also to look at the unison of values exceeding thresholds within them. So right here, I have loaded within DESI the probability of the wind gust exceeding 30 miles per hour from the NBM. Maybe we're curious of where that overlaps the RH, less than 25%. And to do that, you just can click your number of variables. We'll click that to 2, and then we can set a new variable here and a threshold there. And actually, that might not be available from this data set. I might have to load, let's try this one here, if that will give me RH. Yeah, that will give me RH here. And so we can look at that 2-meter relative humidity. That is less than 25% as well. So where do those areas overlap? So here's Saturday afternoon in Rapid City, CWA. Notice those probabilities are pretty low for fire weather concerns there. And that's where local knowledge, of course, and topographic influence comes in real handy, which some of this lower res guidance might not be able to indicate here in parts of Wyoming, for instance. But then as we go into Sunday too, those probabilities are pretty low. They're under 25% for fire weather concerns. So just wanted to highlight that ability to look at a unison of data sets here. So that's sort of the walkthrough on the forecast process. And the last thing that we do is communicate. And so that's our key messages here. So I'm going to ask here if Rich and Sean, how are you with some draft key messages here?
Still working away, under development there, Matt.
Yeah, Matt, we got 3 of them and putting up a 4th one right now, but I'm happy to discuss the 3rd if you would like.
Sure. Yeah.
Three. You know, so Rich and I focused on, and sorry, my camera's kind of bugging out because I accidentally turned off everything with my feet, my cameras and computers with my feet during your presentation. So it's messed up. But, you know, we really wanted to focus on the warm conditions over western South Dakota there on Saturday. So one of our key messages that we wrote was confidence remains high, and we put greater than 80% in high temperatures near or above 95 degrees Fahrenheit for low elevations on Saturday there for Rapid City. And then we also, and I'm sharing right now, then going with that would be the confidence remains high, greater than 88%, and heat indices of over 100 degrees Fahrenheit for much of eastern Nebraska on Sunday. One other key message that we wrote was record warm overnight temperatures Saturday night will lead to poor relative humidity recovery in the Black Hills Saturday night to early Sunday. And that's where that was written more for the fire weather partners there in the Black Hills. You know, that poor relative humidity recovery is one of those watch out situations for them. So that's where that local knowledge really comes into play. Thing about key messages, and Matt mentioned, is, you know, you're vulnerable here writing them. So we would appreciate any feedback that anybody wants to add, and you know, if there's a way that we can improve on them.
Yeah, thanks, Sean and Rich. And as noted, feel free to either raise your hand or type in the chat any thoughts on those key messages here. And like Sean said, we're sort of vulnerable here. We're doing it in real time too. We didn't plan out key messages ahead of time, so we're sort of doing this as we look at the data here too. Or feel free to add in the chat any data set or that we could have looked at as well that might have helped with crafting key messages that we may not have looked at in this particular walkthrough. Yeah, what I like that you did, Sean and Rich, just that high confidence there. I think we sort of went through the checkbox of failure modes, at least as we thought of them, for knowing our general region here. And in general, we were free of them, especially Saturday in the Black Hills area, and Sunday as you head toward Omaha and that. So I think it's a good opportunity, and then to quantify that. And that's a big part of the modernized forecast process, our ability to give numbers to these words of estimated probabilities, or WEPs, to provide some type of context to that. That's really something you'll see in our vignette training that we encourage with our key messages and other messaging that within this MFP. Do we have anyone from Rapid City or Omaha on too? Might have some direct thoughts on these or some things we might not have considered. Not hearing anything. They really like your key messages, Sean and Rich. I think from that word cloud though too, maybe more coffee needed too as well.
I will say this, one of the difficulties I was having trying to write a key message was for that uncertainty for a Saturday, especially for the Rapid City area. So we know that there's, generally the progression of that trough. So I was wanting to tie in into the confidence with high temperatures near above 95 on Saturday, then wanted to tie in something for Sunday, considering a lot of people will be out in the Black Hills enjoying what that has to offer. But then I started getting way too long and wanting to keep putting the Y in there. So I struggled a little bit trying to get that key message.
Yeah, that's really good feedback on that, Sean. I'm with you. I have that too. I want to explain why the probability may not be, why maybe more toward 50%. We feel like we want to add to that, and the AFD content is where we can do that. Yeah, I can understand, and there may have been more that we can dig into and look at to help quantify that Sunday expectation there, but it looks like a pretty wide range there in possible temperatures. Yeah, Rich.
Just a little note. I mean, typically we probably wouldn't have as many key messages, but we've got a kind of a supersized forecast area for this scenario with a couple locations to look at, which adds to the challenge. But that is, that's part of the exercise in increasing the complexity. Did you hear me on that, Matt?
Yeah. Thanks, Rich. Yeah, no, that's a good point. That makes us thankful at times for our forecast areas not being numerous states in size, because there's lots to look at in our central region. So yeah, thanks, Rich. That's a good point. So we're sort of inflating the number of key messages a bit just because to get some weather, much like Jenny's walkthrough back in late July. It's not super active in terms of severe weather in the days 3 through 5, 3 through 6 period there. But we did talk about some convective influences in or near Iowa there Friday night, Saturday morning, and then a little east of there Saturday night, Sunday morning. And one last call for any thoughts or discussion there, and any of the data sets that we looked at, any feedback here on this, or how you've seen the MFP in your office too. Any feedback on that, we certainly welcome. And one thing I'll mention too, one of our deliverables that we hope here early this autumn, or we plan on, is some supplemental information from some of these training vignettes and these trainings that can plug right into your local training and reference material for MFP and key messages. Maybe we'll have a regional sites for it, but it might be best too, for some early feedback from the Northern Plains Sioux community, that maybe that is integrated into our local training information, that we provide some succinct information on the process and the steps here, and some of the tools and references to that. So I know a lot of offices may have local content, local training pages. I know we do here at DVN, and Grand Forks has a great reference page for key messages and the modernized forecast process. But it's a great thing to be talking about with your shift colleague. And that's one of those operational things, especially on day shifts, but really all shifts, but deciding how to approach it in the workflow, and that the one digging into the forecast maybe a little more, and the one communicating and messaging are in regular coordination. And what part of the shift do you start drafting those key messages? Or do you start right away with those inherited key messages and tweak or broaden or add or remove them? So that's part of that kind of local learning of this. And we're real excited to get feedback as we head into the cool season on this after we release our training vignettes. So you'll hear more of that likely from your Sioux. But not seeing any other chatter or any raised hands, we'll probably end today's call. And we appreciate Central Region having us on, and thank you, Mike, for hosting us here today. Everyone have a great day.